good? All right, so next part of this section. So what we're gonna see, we've learned 3 different tests to find information about polynomials, being how many possible positive and negative real roots they would have. How do we figure out what would be the number of potential, or I'm sorry, not the number, but what are the potential roots that it would have, so the specific numbers, and also a very simple one of figuring out how many max solutions something would have, which is always the degree. So this is the exact continuation of the last example that's in your notes. We're going to pick right up with it, finding all real roots of this polynomial. And again, we learned the more general information in the last video, but now what are the actual x-intercepts of this problem? Okay, now here's what we have to do. I listed, this is in your notes from last time, these are the numbers that are the possible zeros or solutions of this equation. That's where I start my thinking then. And what I have to do in your notes here, make sure this is down, we have to use division to figure out which potential roots are the actual solutions. Because if you count up here, there's going to be 2, 4, 6, 8, 10. These are 12 different numbers. But I know that this can have a maximum of 3 actually being solutions. So what I have to do is find values from that list where when I use divisions, they give a remainder of 0. That's how I know that it is a solution to the polynomial. So what I'm going to do, I'm going to simply start from my list and pick one. Start with positive and negative 1. Or I'm sorry, I'm going to start with positive 1 because doing the test, I did learn that we might have one possible positive answer. So let's try positive 1. So I'm going to put this in my synthetic division template. And once again, I'm just going to go off of my original coefficients across the top. So 2, 11, negative 7, negative 6. All right, so what I'm going to do here, good review, I'm just going to go right through the synthetic division process. We'll see what this means at the end. Drop the first one down. 1 times 2 is 2. 11 plus 2 is 13. 1 times 13 is 13. Negative 7 plus 13 is 6. 1 times 6 is 6. Negative 6 plus 6 is 0. Which means I got what I was looking for in this case. We got a remainder of 0. So off to the side here, this is very important. Since using x equals 1 yielded a 0 remainder, it is one of the solutions. And again, we found that there might be 3. That's what the degree tells me, but I know that that has to be one of my 3 possible intercepts that we found. All right, now here's the long way about it. I know that's one of my answers. I could go through and continue trying the synthetic division process with what is left over in my list to try. It's a really long and inefficient way to do it. Now what we're going to do, however, is look to use factoring strategies. Okay. Another really important note off to the side here. Since x equals 1 is a solution, think about how we came up with in the synthetic division section what number goes here. If 1 is a solution, it means that x minus 1 is a factor of the polynomial. So here's what I can now do. So what I'm going to do here to finish is write what's called the depressed polynomial. Okay, this we've done before. Before it was simply the answer to the division. It was this. So the original started with an x cubed, which means that this coefficient now is going to be 2x squared. All right. So again, what I'm doing is I'm reducing my polynomial into its factors. I found one of them. So that's what I'm going to start with. X minus 1. Multiplied by, think factor, what is left over? 2x squared plus 13x plus 6. Okay, I want everyone to take a look here for a second, kind of stop there. I know this is a new idea. Again, to recap what I did, essentially I divided this polynomial so I could have something times something else to get me back to where I started. And what you would find is if you double distributed this to this, you'd get exactly back here. That's what factoring does. I'm breaking it down. It's a little bit more complex of a procedure, but it's still all doing the same thing. So I wrote the polynomial, the depressed polynomial, broken into factors. I need to now go farther. So what you have at this step is to think any factoring strategies that we could use on what is now here. And again, if you wanted to, you could do synthetic division from here and go farther than that. However, this one does factor. And again, without going over the factoring strategy, it is something that you should be familiar with in order to be successful in this section. This is going to be 2x plus 1 times x plus 6. So again, what that is, these are the two factors of this. 2x and 1x, 1 and 6, and then if I FOIL, they would also sum up in the middle to the 13x term that is there. So again, what I'm now doing, well again, let's go to our end goal once again. We're trying to find all real roots of this. What we use to find them is synthetic division and factoring strategies. Now what I think, this is the easy part. I list off my 3 solutions. This one I already found. What numbers make this 0? So again, what I'm doing just to technically write it, x-intercepts mean that I set the entire equation equal to 0. Okay, and I already found that one of my solutions is positive 1. One solution is, so think if I were to do a quick 2-step equation, subtract 1, divide by 2, one solution is negative 1/2. The other solution, think what plus 6 is 0, and the answer to that is negative 6. So that's it. Using synthetic division and factoring, we have now figured out what are our 3, and again, we knew that we would get a maximum of 3 x-intercepts to this equation. The other thing that I would like to emphasize is all those checks we did, if you flip back to your notes, and I want you to compare this, look at the answers we got compared to what we expected to get. First of all, 1, it's in our potential list. Negative 1/2 is in our potential list, and negative 6 is also in our potential list. The other thing that's important to look at is we got 1 positive answer. Go back to Descartes' rule of signs from last section of notes. There was 1 sign change, 1 positive. The other thing, I got 2 negatives. If you go back to the sign change example, you found that we would have gotten 2 or 0 real negatives. We got 2. Everything checks out. That's why we have the test. So again, the culmination of this is how can I find all solutions or x-intercepts to any polynomial? And again, it's all using these strategies. For this video, we're going to go through one more example of going through that process. All right, next. Find all real roots of f of x equals x cubed minus 4x squared minus x plus 4. Okay. So what I would encourage that you do for this one, take a minute, find 3 things. The max number of solutions, Descartes' rule of signs, you do the sign change test, and also using the rational root test, find which ones are going to be our starting points, which solutions. Okay. I'm going to start there, kind of brush for at least this example, hoping that you're good with the sign change process and how do I know what those are. I'm going to find my possible roots first. Well, I will stay consistent with wording I've used. Potential roots. Okay, so factors of the constant, P, plus or minus 1, plus or minus 2, plus or minus 4. Q, factors of the leading term, it's just 1, so pretty easy. P over Q, plus or minus, just going to be that list, because P over Q is just divided by 1. Plus or minus 1, plus or minus 2, plus or minus 4. All right, so again, this gets us our list to try when we do the synthetic division process. So what I would recommend you do, actually see if anybody can do this in a different way. I could actually solve this equation with a factoring strategy right now. I'm not going to do it, but if you know what it is, see if you can do that, along with what I'm going to do here with the synthetic division, see if anybody thought of it by the end of the video anyway. So again, what I'm going to do now is I'm going to set up the synthetic division process. Now what I want to also do is show you, it's not going to work out every time. Normally I would start with positive 1, and I actually know that that one does work. However, I'm going to start with negative 1, and I want to show you what it looks like when synthetic division does not work, and you have to try something else. So if I do negative 1, fill in the coefficients across the top. That would be 1, negative 4, negative 1, and 4. 1, negative 4, negative 1, and 4. And go through the process. Drop the 1 down. Negative 1 times 1 is negative 1. Negative 4 minus 1 is negative 5. Negative 1 times negative 5 is 5. Negative 1 plus 5 is 4. Oh, darn it. I did one that did work. I apologize. Well, we found something that's going to work. Let's try this again. I know that 2 does not work. Again, I always personally just start left to right and try things. But again, I want to show you one that does not work, where you would have to be, forced to try something else. If let's say 1 or negative 1 didn't work. Plug in 2, drop it down. Let's try this again and see if I can actually fail this time. 2 times 1 is 2. Negative 4 plus 2 is negative 2. 2 times negative 2 is negative 4. Negative 1 minus 4 is negative 5. 2 times negative 5 is negative 10. If I add this column now, I get a remainder. So let me emphasize, when we do not get a remainder of 0, this is not one of our answers. I have to scrap that whole process, try something else. And again, I know I did find something that worked last time. So let's go ahead and try negative 1, since I was on that train anyway. All right, so again, my coefficients across the top. Bring 1 down. Negative 1 times 1 is negative 1. Negative 4 plus negative 1 is negative 5. Negative 1 times negative 5 is positive 5. Negative 1 plus 5 is 4. Negative 1 times 4 is negative 4. This is what we get that tells us we know we have a solution now. Okay, so once again, now I'm good to go. I can continue and write the depressed polynomial. And once again, this is a solution, negative 1, which means if that is a solution, x plus 1 is a factor. And that's always where I want to start this next part. Okay. So again, if negative 1 is a root, x plus 1 is a factor. So I'm going to start there. And what that is multiplied by is what is left over here after the division process, as we've seen in different sections. So if the original started as an x cubed, this is now a 1x squared. Minus 5x, just go right on down the line, plus 4. Okay, now that we've done the synthetic division part, now we look to factor what is left over. And again, I'm finding zeros for finding roots, which means that I fill in 0 for y, or for f of x. Okay, and here's where I think this is a pretty straightforward 3-term factoring problem. Factors of 4 that add up to -5 are -4, -1. So x minus 4, x minus 1. Now it's the easy part. I have 3 solutions that I got: -1, +4, +1. So 3 answers. And again, hopefully if you did go through and test the number of sign changes, this all lines up that you should have gotten possibly 1 negative and possibly 2 positive answers. Once again, if we do our check, we can see that the answers we got, -1, +1, and 4, they all fall in this list of possibilities. So again, it all connects. Last thing in this example, hopefully what you recognized, and again, you can always do the synthetic division process, but I actually could have factored by grouping. Those of you going back to the last homework assignment or a couple ago that I would have given, factor by grouping would have worked here also, and you could have gotten your solutions that way. So again, that wraps up what we are doing with what's called finding real roots of polynomials, tying together all of our factoring strategies in synthetic division. Once again, there will be suggested homework to finish off this section posted on Canvas, and next video will be section 5. So, thank you.